I still think scanning is important, but it's only going to give you a picture of like vulnerabilities that are known at a point in time. And those vulnerabilities might be super important. So we really need to, not deploy that image, or we know we need to update that image. But there is just so much scope for 0 days. And as I say, that, people using AI to discover these new 0 day exploits, we need that runtime ability to spot malicious looking or suspicious looking behavior at runtime.
Well, I suppose that does segue us nicely into the eBPF questions. I guess back when the first edition came out, there were very few, especially for enterprises that have deployed lots of their own on-prem, they're sort of sitting on old kernels. So there were much or far fewer systems that could actually run eBPF because the kernel hadn't been upgraded to the latest version. Um,
Mm.
how have you seen that impact the thinking?
Yeah, I mean, so eBPF has been something I was interested in. I remember seeing Thomas Graf presenting about it at a DockerCon back in the early days, when I was first thinking about like even what is a container. And seeing this eBPF technology, thinking, well, this is amazing. You can have a customized kernel, but you know, I basically have to build my own kernel at that time to take advantage of eBPF because it wasn't built into any of the mainstream distributions. And over time, that obviously became more and more commonly included in distributions. And I think the real turning point for enterprise was Red Hat Linux, including eBPF in there. I can't remember which version it was now. I want to say 8. Um, but as soon as you have, enterprise Linux with eBPF capabilities, that opened up a whole world of opportunity for runtime, observability, and security. So that made a huge difference.
Yeah, and absolutely. The unlocks on the back of just those kernel versions getting to maturity really helped with a huge number of things. Um,
Mm.
okay, so
Do
I
you
suppose
see that as well? I mean, in your experience of working with consumers of this kind of security tooling, do you see an increased emphasis on that kind of runtime tooling now?
yeah, absolutely. The first of all, it was we had Falco, which had to have a kernel module compiled in to actually do any sort of
Mm.
detection. And that traditional, we saw the CrowdStrike issue with kernel modules being baked into various things. The issue with crossing that into kernel space, really from user space, is there's no API. It's plugging into what often is sort of undocumented or hope and prayer related things. So abstracting that out into, even though eBPF still has the ability to execute down in the kernel and hook into those things, the speed at which that happens and the fact that there is a way of testing it and it's actually linked to documented APIs made a huge confidence difference to
Mm.
consumers. And then, I mean, the performance benefits, sort of thinking about how Cilium turned up. Everybody wanted to use Cilium, but generally estates were fragmented enough. And then at the point that I think when GKE adopted the data plane V2 forked
Mm.
from Cilium, at that point, the confidence in the technology backed off with the fact that they'd made that decision partially based on data center installs for hybrid customers has made a
Mm.
huge difference. And it really is that
Mm.
lightweight element with the confidence, and suddenly we can squeeze more performance out of all our capital expenditure and investment in the first place. So, yeah, certainly. In the process of, we actually threat modeled the eBPF runtime for the eBPF Foundation
Mm.
last 2 years ago, I think it was. And the way those security boundaries shift from basically a lot of synchronous, sort of layered and slow blocking. You can run 3 layers of app armor, I think, if you really want to, but it's undescribably slow. And it's the same for
Yeah.
Kafka Flink
Yeah.
with Trump. And so all of a sudden, those things collapse down into one defense surface and attack surface, and it's just made reasoning about the systems much easier as well.
Mm. Mm. Yeah, and I think that performance overhead is really it's really important when we think about security tooling that we're using tools that don't kind of sort of DDoS ourselves by running like really slow tooling. Yeah. So that has been one of the real emphases on, from eBPF in itself being really lightweight. And then with projects like Tetragon, where you can filter out events within the kernel so that you're not streaming a whole fire hose of, every time anybody opens a file, you don't want to send that to user space. You don't want to log every single file open, but you want to know when somebody's looking at a sensitive file or opening a suspicious network connection. And that kind of granularity is a real impact on performance or the very low overhead of projects like Tetra.
Yeah, and I suppose to that point, it's not a classical security vendor play in the sort of in the abstract world that we've been in for the last 30 years or so, to prioritize performance in general.
Mm,
Often the absence of false negatives is the most important thing, and so we tend to get overloaded with things. Developer experience and runtime performance has not been a consideration. So certainly that kind of huge shift as we went from eBPF being built for performance in the first place and then moving into enforcement has definitely changed the industry, dare I say it. I'll have to be careful what I say, perhaps. Wonderful. Well, I suppose from what we've had historically then, um, do we think container security is even the right term anymore as we've moved into cloud native, as you've mentioned? Is it wider than this?
that is a great question. And you mentioned customers using hybrid cloud environments. We see so much more uh, integration across, multiple Kubernetes clusters, not just different regions, but maybe running in completely different clouds. Maybe they're hybrid between, public cloud and an on-prem deployment, and maybe they're also interfacing with services that are running in VMs. This uh, I guess when we were first thinking about containers, we were thinking about them very much in a kind of greenfield sense. And nowadays, containerized apps are really just part of a bigger estate of workloads that could be running, yeah, in all these different environments. So I guess one thing when I was doing the second edition, I didn't want to change the title of the book because that's the title of the book. But I did change the tagline from protecting containerized applications to protecting cloud native applications because I think cloud native does encompass a little bit more that multi-cloud, multi-environment sense. And that's really important. I think we're increasingly seeing a lot of these um, deployments where people want to have tooling that reflects all these different environments. They don't want to be having different tools for, Kubernetes and different tools for their Lambda functions and different tools for their VM workloads that are running in their on-prem data center. They want to bring as much as they can to bring that into one interface, which is a real challenge.
Yeah. I must admit not having noticed the tagline change, which is very inept
Subtle.
reviewing, perhaps. Yeah. I mean, I completely agree with your points. The difference between the sort of a micro VM and a container, and then whatever isolation technology is chosen for sort of Lambda and serverless, while they have common lineages, the implementation is very different. And so the instrumentation really varies as well. I suppose one of the questions I think that I spent the first few years of my cloud native career being asked and trying to answer correctly was where is the isolation boundary on a container? And the question I suppose is if we ask that question now, what is still the biggest misunderstanding about container isolation?
Mm, mm. I mean, for years, I feel like I was having to just reinforce and reinforce and reinforce that each of your containers does not have its own kernel, that they're sharing a kernel. And while that, eBPF helps us in that world because they're all sharing the one kernel. But the fact that you have this single kernel across different containers and the kernel does not have um, there's no sort of kernel native concept of a container. Containers are built up of these, namespaces and C groups. And so the Linux kernel itself is not really going to do a lot for you by default to isolate your containerized workloads. It's a very, I mean, I do think it is a security boundary of sorts because it is something that you can secure, but it's a very, very, very porous boundary until you put some hardening around it. And, you bring up things like lightweight VMs, which I think are really interesting. And, you know, if we can get that balance of speed and security and instrumentation and observability, they can be really a really interesting direction.
It's yeah, funny you mentioned that instrumentation angle. Obviously, when I remember you introduced me to Mr. Brandon Lum at KubeCon China
Oh yes.
in 2018 or 19, and he was part of a research lab that were doing a lot of work into unikernels, which is kind of somewhere in
Yes.
between the container and a micro VM. And the persistent problem that we always had trying to either help customers with proof of concepts for this kind of thing is that instrumentation and observability. Because if we've removed a load of syscalls and we don't have direct kernel access to instruments, then so unikernels have kind of fallen away a little bit. But what we've now got with Firecracker and gvisor as well to some extent is kind of in those directions. But then it becomes that almost a sort of devil's bargain for, well, do you want something that's completely isolated so that you can't even see into it? Or do you want something that is isolated with good runtime instrumentation so that you have that view? And I think what's most interesting now is that there are multiple options at each slice of that spectrum. And yeah, kernel sharing is a feature in some of them for sure.
Yes. Yeah, absolutely. That is, I guess, to my way of thinking, the fact that you are sharing a kernel is almost the definition of a container. Aside from that, because they're just processes, and things like, I mean, actually, a lot of the defaults have been improved. But if you just take a regular Docker container and run it on a Linux machine, and it's running as root, and it's root on the host, and I mean, that's actually another really good example of something that has improved a lot because we can run containers as rootless, so they're not necessarily. Um, but back in the first edition, it was just inevitable that root in your container was root on the host. Yeah, so
Yeah, you've reminded me of Jesse
actually a really
Frazell.
nice. Sorry, yeah.
Oh, it reminded me of Jesse Frazell's contained.af, which was
Haha.
all
Yeah.
about those isolation boundaries. And yeah, I mean, using namespace is a great example. It took longer to get performant, well, robust kernels than it did for eBPF to some extent. But again, there's a lot of effort from Red Hat there with Podman. But that is a huge. That's probably one of the biggest structural changes to the container ecosystem over the past God, 5 or 6 years.
Yeah, huge. And I think very complex changes in the kernel. I wouldn't begin to pretend to be an expert here, but I think a lot of the implications of user namespaces, we wanted them because of security, but they touch so many different parts of the kernel. So it was a really complex change to make.